Um, I think we'll just get going since it's 3 minutes past now. Welcome to today's session on decarbonising heritage buildings. I'm Dan Leeming. I'm a consultant here at Turner & Townsend, joined today by Alistair Cameron, the regional director at ECD Architects. I think there's just a few before we get into it. There's a few points of housekeeping as well. So if you could just keep mics muted, cameras off for the duration of the presentation, and I think then we'll get into a bit of a Q&A towards the end. But other than that, I think there'll be a little poll at the end as well, a little feedback poll which I'll pop in the chat. And yeah, there's a couple of other little links and bits and bobs that I might be popping in there throughout the session as well. So just keep an eye out for those. But otherwise, then, on behalf of the North Eastern Yorkshire Net Zero Hub, TNT, I'll hand over to Alistair.
Thanks very much. My name's Alistair Cameron. I'm a regional director at ECD Architects, and I'm going to be talking to you about decarbonising heritage buildings today. Just on particularly one of the case studies, the feasibility studies that we've carried out. So we will be looking at the municipal building in Inverclyde Council, which I'll tell you about in a wee second, but just a brief intro in ECD. So we've been carrying out sort of retrofit feasibility studies on sort of large non-domestic buildings in the States for about 4 years now. We started off with the Strathclyde University. We looked at the entire campus in terms of retrofitting all of their buildings to the ENERPHit standard, and kind of took it from there essentially. And I think we've learned quite a lot over the last 4 years about what not to do and what to do, and actually what's achievable. So we've probably changed the way that we do things a bit actually over that time, learning quite a lot from clients. So hopefully that will come through in the presentation a little bit. But just if you are not aware, and you probably aren't, Inverclyde is in the west coast of Scotland, just maybe about 20 miles west of Glasgow, so still in the central belt, but it's quite a small authority. And this is Greenock that we're looking at here. So I don't know if anybody came to the last presentation I did with my colleague Amit from RIBCA. We did a presentation on the Waterfront Leisure Centre. And the study actually covered a historic building called the Municipal Buildings as well in Greenock. And actually the idea was, I'm not sure if you can see the pointer here, but the idea was that actually we were looking at retrofitting these buildings and potentially putting an energy centre, water source heat pump centre in the bay there, and we're going to look at how we could potentially bring in like the local police authority, and there's a college building and an art centre there as well, and just run it off a district heating system. And that's quite a key thing to consider when you're looking at retrofitting heritage buildings, because they are difficult, technically challenging, and they use a lot of energy. So that is one way to look at it. It can be done without that, obviously, as well, but it should be considered. But this is the building that we're talking about here. So it's a beautiful Grade A listed building. I'll talk to you in a bit more detail about it, but the sandstone element on just to point this out, the sandstone element on the left-hand side there, that's a facade retention project. So there's a newer building sitting in behind that I'll show you in a diagram later on. But pretty complex, as you can see. And a lot of historic value. And we started off our journey, like I say, when we're talking about ENERPHit, when we started working with the University of Strathclyde, and that's what a lot of clients kind of look at, when they're asking for things in retrofit. At the moment, it's the buzzword, but there's a lot of challenges when it comes to ENERPHit, particularly in retro. Well, sorry, ENERPHit is retrofit, but there are a lot of challenges, and basically you kind of get yourself into this kind of cycle, where ENERPHit's expensive anyway, retrofitting buildings is expensive, but doing it to that sort of level is very expensive. But then when you factor in the occupancy levels, particularly in non-domestic buildings where you've got maybe sitting tenants in there and you have to work around them, and that can be as a result of there's a lack of decant space quite often, so you have to work around them. That restricts your access, and that actually means that technically it becomes more challenging. and it then becomes more expensive, and round in sort of circles. So, you know, there are a lot of difficulties when it comes to looking at EnerFit, which I'll come on to again later on, well, just now actually. So when we look at the methodology, we kind of changed what we were doing a little bit. So obviously we start off, and I'll go through these in a bit more detail, but you've got to understand your building first that you're looking at. So you're really looking at carrying out quite a detailed building survey and initial analysis. And then what we tend to do is we tend to model that, then create an energy model in 3D using the Design PH software. So we use the even although we wouldn't necessarily be retrofitting a building like this to Passive House, we still use the PHPP Passive House software, because we find as designers it's the best one to use. It's the most accurate, and when you're actually designing detailed buildings, it makes you go into a lot more detail, and the thought process is more complete, I think, when we use the PHPP. Now, the PHPP won't capture things like overheating in a building this size, so you'll be looking at probably an IES model working in conjunction with the PHPP model. But for us, I think as architects, it's better to use the PHPP for our modelling. So we do a thorough existing analysis of the building. We take that information, put it into the PHPP, and create an existing PHPP model, and then we identify potential proposed retrofit measures that can be undertaken. Plug that into the PHPP analysis, decide how that's going to work, and if there's different levels of that, get it costed, and then the client falls off their chair, obviously, and nothing really happens beyond that. But they get a nice report out of it, which is good. So when we looked at the building, this building initially, it's really split into 4 different sections, and that is important, as I'll come on to. So there's this retained facade element, which is now on the right-hand side, and behind that there's the sort of more modern Drummers Close building. We've got the town hall in green, and then we've got the main sort of municipal building, which is in white. They're wrapping round. And we've got a couple of towers as well. The important thing about the towers is, although they are incredibly difficult, obviously, to try and retrofit, but actually when you're talking about retrofitting in PHPP and Passive House, they're outside of the building insulation envelope, or at least you can make them outside of the building insulation envelope, and that means that you don't need to worry about them particularly in terms of that element. So that's what we were proposing to do there. Obviously, still be wanting to put some sort of trace heat through it to prevent any rot or anything like that, but you can kind of cut the insulation envelope at that point, and then that makes your life a little bit easier. So you really need to go through that analysis at the beginning and work out exactly what bits you're interested in and what bits you're not interested in. And then going into it in a bit more detail, actually undertaking the building survey. So on this particular building, so this had a complete labyrinth of rooms in the basement, so you could get really good access actually into a lot of the spaces. There's access to the soffits throughout the building. But obviously there's walls everywhere as well, which are creating cold bridges, and that was a cold space. There was no heating in the basement. Up on the ground floor, and you can actually see that there's a bennel created between the 2 buildings, which has now been enclosed, and it's a really quite beautiful street, internal street there. But obviously more challenges there as well in terms of insulation. And then as we get further up the building starts to drop away, and the form factor gets a little bit worse. You can see some of the nice sort of domed areas in the town hall there. And then as we get up, we get more roof spaces, which could be retrofitted, but you can see the difficulties there in terms of access that could potentially happen. And then up onto level 3, that was actually a new build extension, or rooftop extension rather, and some of those rooms really have no real heritage value. And just coming on to the historical significance and heritage value, you've got to understand that in these buildings, because it's a very limiting factor. So we went through each one of the floors, and we've got an in-house conservation architect, luckily, who went through each of the floors and just identified which rooms really we could and we couldn't do, because when we're talking about when we're talking about historic buildings like this, obviously you've seen the outside of the building, there's no way you can overclad that, that's obvious. So you're really talking about potentially internal wall insulation, but again, when you're looking at a lot of these rooms, there's no way you can really touch them. I know it's been done in the past, but it's an incredibly expensive way of doing it then, and I think it's really probably only appropriate to a very small number of buildings. So buildings like this, where it's a council, very limited budget, these rooms, there's really not very much that they can do with them, and you need to understand that at the outset of the projects. And I'd mentioned to you as well, obviously about the sandstone buildings. And again, it's important to understand how those walls are actually performing. So we undertook in situ U-value calculations here, and this isn't the actual result. This is from a table from Historic Environment Scotland, but this table does show you quite well what the U-value calculated would be if you were using a piece of U-value software versus what the actual in situ U-value measurements were. This was in a tenement in Glasgow, and you can see there, particularly in the first floor flat here with the wall to the stairwell, you know, the wall's performing much worse than what the calculated value is. Again, you've got to understand that because quite often you're basing capital investment on these kind of things, and this is where the well-known now performance gap starts to slip into these buildings. You know, if you don't understand how your building's performing at the moment, you're never going to get the result out of it that you want. You know, it's just like the old rule, you know, put good information in, you'll get good information out, and vice versa. I'd mentioned to you as well, there was 4 different types of, or 4 different buildings there. And again, it's really important to recognise that and take that into account when you're actually looking at how you retrofit the building. There will be different types of stone in each of those buildings. They'll all have different types of porosity. They'll perform differently, and there's actually different levels of risk involved in retrofitting those, particularly in terms of internal wall insulation. And you really do have to be careful. There's a lot of risk involved in this kind of thing. When it comes to retrofitting historic buildings. So you've got to do that analysis, you've got to understand the porosity, potential for mold growth, all of that kind of thing, and identify the different periods where the building's actually been constructed. And again, this is this was actually the result of one of the tests that we carried out, and really interesting. We're using Woofy software to do this, and actually what's shown us, you know, you cannot simply go in and dump 100 mil of insulation into a building, internal wall insulation into a building like that, because you will risk rotting the joist ends that are in the building there, and it's kind of slightly counterintuitive. So you can see that in the table on the right hand side there, actually the blue line, the blue bar that's going across is where the risk is. Essentially, anything above that is where you start to risk timber rot in the wall, and you can see that actually the 50 mil of diathanite insulation is fine, but if you go up to 60 mil of diathanite, then there's actually a risk there. So it's a real limiting factor in terms of what you can actually do to these buildings here, because this is a typical detail with your joists sitting in the wall there, and if you put 60 mil of diathanite on that vertical element there, then that joist is going to start rotting potentially. So again, those calculations really have to be done at an early level, at an early stage rather, at feasibility stage, before you can start to make decisions about how you're going to fund these works, and indeed whether you're going to do them or not. But like I say, you take all of that information, you plug it in, you put it into the PHPP software, or we do anyway, and it gives you this sort of nice bar chart here. So we can see here that we're using 275 kilowatt of energy per square metre per annum, which we would probably expect a building like this to be using, but it also gives us some information, good information on how the building is actually losing the heat there. So you can see that 32% of that is going out through the insulated stone, so a big chunk of that has been applied to that. In this particular building, the pitched roofs had already had rock wool insulation laid on the flat, so there'd already been work done there, but the flat roofs had never been upgraded, but it was performing reasonably well in comparison to other things. And also you can see in the floor there, although the floor is completely uninsulated, on the graph on the left-hand side, you can see it's actually hardly losing any heat anyway through the floor. So arguably, there's not much point in actually doing anything to that. And the windows were different levels of upgrade. So they had actually upgraded a lot of the windows to double glazing, but you can see there that the infiltration loss on the left-hand side is still quite high. So potentially some of those windows, although they're probably good windows, they haven't been installed very well. So again, is that a case of replacing the windows, or is it actually a case of taking them out, just reinstalling them in a better manner, and to improve those? All of that kind of thing needs to be thought about. And it's good to understand your energy targets as well, and where you could potentially get to. So you can see here, These are existing buildings in the UK, so you can see that the average is probably sitting at about 130 kilowatt hours per square metre per annum. And obviously you've got your passive house and Enerfit and all sitting down there at the kind of low level. We're never going to get down to that kind of level probably with the building that we're looking at, but it's good to know where you sit then in relation to some of these other targets, and if possible try and set a target for you to reach over the next 20 years, for example. So moving on to the improvement measures, it's all the standard stuff that you would expect, from a kind of passive house approach. So trying to get continuous thermal insulation as much as possible, improving that air tightness, like I say, high performance windows and doors, minimising thermal bridges, getting efficient services in there, which is also a very big thing as well, actually making sure that they're running efficiently. But what we try to do as well is make sure that we're making it climate ready as well. So, testing any improvement measures that we do against, the next 20-year climate models, for example, increased rainfall, all that kind of thing, is really important to take that, take cognizance of that, so that it's climate change ready. And what I said, we'd kind of change our approach slightly from those early studies, and where we've got to is, like I said, we know that clients, generally speaking, cannot afford to just strip everybody out of a building and spend £10 million doing one building, or even more than that, and then popping everybody back in. So really where we've got to is a phased approach and trying to look at different levels of intrusion. So phase one's what we've been calling shallow retrofit. So actually what can be done light touch by just going into a building with the people still in situ. How big an impact can we have on the energy or the heat demand rather in that building? Phase two is the deep retrofit. So again, more intrusive work there, maybe a little bit of decant. But what else can be done there by to try and lower the energy, the heat demand, sorry, and particularly the heat load. So one of the key things about retrofitting these buildings we've found is actually the load rather than demand, and trying to get that load down enough so that it becomes sort of heat pump ready, essentially. And often we find that that's where the sweet spot is actually in terms of cost of retrofit. And what the client's actual target is at the end of the day, which is decarbonisation of their assets. So that tends to be where we try to get to. And then just for knowledge, we go full retrofit as well. So what would we need to do to get this to Enerfit standard? And that tends to be where we start off and then work our way back. But 9 times out of 10, it's not really achievable. So phase one, what kind of works are we talking about? Well, and particularly in historic buildings, we need to focus on maintenance and repair first and foremost. If the lead work in walls is poor and the walls getting damp, a damp wall will perform many times worse in terms of its heat loss than a dry wall. So it's often overlooked, but this kind of thing should be done as a kind of first stage, just repairing the stonework, repairing the lead work in these buildings and making sure that the building fabric as it was designed is performing as well as it possibly can. And you should be able to see some significant savings in energy if you go around and do that. Other small items which aren't particularly intrusive, external door upgrades can have a decent impact. Quite often they're limited as well with the amount of work you can do to them if it's a listed building, but you can install insulation into those panels, aerogel insulation and things like that. Typically you'd expect me to talk about windows as well, and that would normally be a good option, but just in this particular building, because the windows had already been upgraded as part of one of the later packages. And then roof upgrades as well. Like I say, the pitched roofs had already had insulation laid in them. We could increase that, but actually what we'd be looking at is targeting the flat roof areas. And like I say, a lot of these are quite difficult to access. So you need to take cognizance of that and see if it's actually worth doing that. One of the big items that we can be targeted is external wall insulation, which I said we can't do. But when it comes to secondary elevations, you absolutely can. So in this building, there was a number of internal courtyards, and it was really just sort of brick facades that were in those, and all of those could be treated. So you can see there the yellow areas. There's a couple of orange areas where the building has actually already had a bit, but all of the yellow areas in those plans are available for internal wall insulation. And do not ask me why that section has not been insulated. Nobody in the client side could tell us what was going on there. So I don't know if it was a architectural design feature or something, but and then what, like I say, window improvements. So this was coming down the sort of list of the initial interventions that we could do. And typically we'd be looking at a secondary double glazed secondary glazing, installing that into the windows. And you can see there in the graph, or sorry, the chart, you can get some really significant improvements in terms of your energy loss there. But in some buildings, particularly grade A ones, you won't be able to even do that, depending on what's going on inside. And it's an interesting chart, because even things like putting in Victorian blinds and shutters and things like that, 62% saving over typically what the window would be losing is not to be sniffed at, really. Unfortunately, it's not a passive measure. Somebody's going to have to go around and do that. But there are still options available when it comes to retrofitting, very high quality historic buildings. So phase 2, getting into the sort of deep retrofit side of things, then we're talking about internal wall insulation there, and like I say, that becomes quite complex. Fairly simple technically in terms of detailing, but undertaking those studies early on to understand the porosity of the stone, etc. We need to do, and then, like I say, comparing the spaces as well. The space on the left-hand side, you wouldn't touch the space on the right-hand side. Absolutely no problem there doing that one. But interestingly, I think although it was quite a big energy saving, sorry, there was a lot of energy lost in the building, which is 35% of the energy loss in the building. When you actually looked at what rooms you could do this to, it was really quite small. So although you can see the lambda value there, it's quite significantly different between the diathanite and the wood fibre and the calcium silicate board. Actually, because it was getting done to such a small area, it made practically no difference. So these are cost considerations, that should be taken into account when you're looking at this kind of thing. And that's why it's important to do that kind of study early on in the feasibility study. And then there was some, phase 3 was the kind of optional upgrade. So there was this sort of weird corner which had been taken away, which obviously a previous building had been sitting there, and they had actually retrofitted that already and overclad it, but they hadn't done a very good job on it. That could have been stripped off. It probably should have been stripped off, actually, because it was PIR installation that was installed there, so it's not breathable, which will ultimately damage the fabric of the building. But again, very small impact in terms of energy savings, so maybe not worth it particularly. Like I say, the basement insulation, that's an option open to us, but you can see from the chart earlier on that there wasn't really very much heat loss through that part of the building. So is it worth it? Possibly not. When you look at the amount of M&E kit that's down there and the amount of disruption that would have to be done, that would obviously be quite expensive, but very accessible as well, which is one plus point there. Curtain walling upgrades. So these were installed in about 2002 from memory. So they weren't really quite at the end of their lifespan. There's still a bit of time to get out of those. And they weren't one of the worst performing parts of the building. So again, if the money was available, then worthwhile doing, absolutely, but probably not top of the priority list. And intrusive as well, particularly in the reception area. So in terms of recommendations then, so using the PHPP, we get this kind of nice waterfall chart as well, where we can get to if we undertake all of the all of the interventions that are available to us. So we've got the baseline in the left-hand side there, and then you can see when you get to the light retrofit phase, you're making some savings, but they're not fantastic. And it's actually when you do some of the internal wall insulation, so that should be out, external wall insulation, apologies, then that actually makes quite a significant difference there. So, but also the other thing is the optional extras in line with maintenance. So these optional extras here, there's quite a bit of money associated with those, but you can see that in terms of energy savings, it offers practically nothing. So questionable whether they should be undertaken. And when it comes to the cost, so the shallow retrofit there, you're looking at about £1.9 million. This study was complete about 6 months ago, so not that out of date. Shallow retrofit costs about £1.9 million, and the heat and demand, you're saving what's that, about 70 kilowatt hours per square metre per annum. So reasonably good. The heat load is, like I say, is the one that we're really kind of interested in, and you can see a significant drop there, about 30 watts per square metre there. But it's not quite getting you to the level that you need. So again, you need to look at the deep retrofit options. Now that is a significant uplift in money then. So that's on top of the 1.9 million. We were looking at another 6.4 million pounds there. A big jump in the heat demand. And the heat load then getting down to the level where an independent air source heat pump system could start to work in this building. And obviously you can put an air source heat pump in whenever you want, but when I say that, what I mean is an air source heat pump that's going to go into the building and not cost you significantly more money to run. So it's trying to get the fabric down to a level where you can decarbonise the building and not be absolutely skint with your energy bills, going forward. And then phase 3 options, another 2.7 million added on to that. But you can see here the difference in the heat load and the heat demand, arguably not worth it if you were to do a payback calculation. I mean, the thing is, with any of these, payback periods are horrendous anyway. That's not really why you're doing it. It's about decarbonising the building. Now, in this particular option, because we were looking at an energy centre as part of this, our recommendation was just to do the shallow retrofit. So just do the easy stuff, bring that down a bit. We did the same thing with the sports centre as well, and we would probably do the same thing with all of the other buildings that were tying into it, just so that we could reduce the size of the energy centre. But it's not worth excuse me, not worth going to that deep retrofit level. If we were trying to do this without that energy centre, then arguably we might be looking at going to the phase 2 deep retrofit, or at least part of that, to try and get that heat load down significantly. So all of these things tie in. Another thing that we kind of pick up is where are the easy wins in these, and they wouldn't necessarily be all sitting in the shallow retrofit. Some of these might be sitting in phase 2 as well. But trying to give the client as much information as you can about the building and how that possibly could get retrofitted, which we'll come on to in a wee second. And excuse me, interesting to know as well about where these potential upgrades get you in relation to the rest of the building stock in the UK. So existing, it's off the chart. We do the shallow retrofit stuff, it's still performing really badly, but if we do the deep retrofit, it's actually not bad for that type of building, for the size of it. It's actually a pretty good result, and if we go full deep retrofit, then it's performing nearly as well as a typical new build building, which would be incredible, but obviously not cheap. So just to kind of conclude, where have we got to with this? Well, having done a lot of these studies, we look at it in, like I say, in terms of a stepped approach and really considering carefully what works need to be done. But for estate owners, it's really important to realise that if we can tie individually a lot of these measures are actually maintenance works, so it's not necessarily new money. So you see that £6 million there, and obviously people will fall off their seats. But if you're looking at doing that over the next 10 years, but potentially about 50 or 60% of that is actually already factored into planned maintenance programs. Well, you would hope so anyway. Probably not really, but it will be at some point. So it's not necessarily new money, and you may tweak the specification to make it a little bit better than what you would normally have put in, but the uplift is not as significant as £6.5 million of new money. So really thinking about how that works, planning those works out over a longer period instead of trying to go into a building and do it all in one go. And like I say, really important to try and set a target at the end, because if you don't do that, you're never going to achieve anything. And this was just a bit of work that we did for Portsmouth City Council on one of their blocks, where we actually had a building condition survey, so we could see what the life expectancy was of the different parts of the building and the building fabric and the MEP. And we could tie that then back to what we had found out in the study and what the proposed upgrades were, and phase them in a particular manner to tie in with that planned maintenance strategy. so that it would work with the client rather than just tossing away the planned maintenance strategy. And it's really important that, and I know it happens quite rarely, but it's so important that the maintenance department, the capital department, the clients are actually speaking to one another, because I think that's the only way that this is ever going to happen. Retrofitting non-domestic buildings is by doing it in this kind of manner, in my opinion. And that's me finished.
Thanks for that, Alistair. That was really, really interesting. Lovely to get properly into the sort of the technical details around some of these, some of the options I think that you have available to you when you're retrofitting these kinds of buildings, which I think for many people probably feel like there's not a lot you can do. So it's nice to hear. I think that even with these sort of very complicated, multifaceted types of buildings, it's perhaps better not to really think of it as a one size fits all approach. It's quite bespoke to individual parts and what you can do, and seeing how those sort of all work together as part of a bigger system. I think then if we open it up then to any questions or points that anybody would like to raise, since we've got quite a bit of time, I think, to really get into some discussions. So if there's any points that anybody wanted to raise, any questions, feel free to pop your camera on, unmute your mic, or if there's any, if you're sort of stunned into silence, are there any particular buildings that in your organizations you're looking at? I'm presuming that some of you have come along today with a particular problem project or problem buildings in mind. So I just wondered sort of what brought some of you here today potentially.
Found out quite a lot of the ones, particularly when it comes to, these are always the problem buildings, I think, and when we're looking at estate-wide sort of retrofit studies, particularly for universities, quite often you actually need to almost sacrifice these buildings. Do you know what I mean? Like in such a way that you've got to over retrofit other ones. If you've got an overall target, for the entire campus, then quite often these buildings are very limiting. So you're better off putting your money into other buildings, I think, to reduce the energy consumption in those ones. Do you know what I mean? Rather than these. But there's definitely things that you can still do, and you can't forget as well, I think, that when we talk about passive house and retrofit, it's also a comfort standard as well. So there are other reasons for wanting to retrofit buildings like this, because if you're working in one of these buildings, it can be pretty uncomfortable in winter. For example, so thinking about staff and employees and things, it's not, decarbonisation is not the only reason to, look at it.
Yeah, and I think that's just reminded me of that point you were raising earlier about payback periods for this kind of work. It's not really you're not doing it just to make a saving on your energy bills. This is putting a bit of loft insulation in your house. This is sort of this is about decarbonising building. It's about building comfort levels. It's these other things which you can't quantify in quite the same manner, but yet still need to be done.
You're better not looking at it. It'll just depress you, honestly.
Yeah.
It'll put you off, particularly as homeowners. But like you say, for non-domestic sort of things, that's not the driver behind it and the rationale. But it's never a good news story, unfortunately.
Yeah. In terms of because when you mentioned heat pumps and getting that down to effectively what we're trying to do with this kind of fabric first retrofit is to get the building to a point where I can put a heat pump in and not cripple myself with the energy bills. Do you? I think currently as a bit of a rough rule of thumb or guidance or whatever it is. I think I think you had it in at getting the space heating demand down to about 100 or 110 kilowatt hours per meter squared per year. Was that what I think I saw on the slide there? But in that kind of the ballpark. But is that largely sort of based on, was that largely based on, estimations around, current electric prices and stuff, or was that sort of taking into account, what, the expected, prices and stuff of electricity, going forward into the future? I'm just thinking here is because there's obviously a lot of charges on electric rates and things like that, which aren't on gas, but that that might not always be the case. Does that kind of thinking factor into your designs, or is it just sort of too up in the air to kind of even consider?
No, absolutely not. No, I mean we had good information from Strathclyde University. I mean they had a district heating system, but it was still running from gas, and obviously they'll need to transition to that in this building as well. So we've got a calculation set up which takes into account energy price inflation. Obviously that's crystal ball gazing, but you've got to do something, and having the information if you are transitioning from gas, so we can present it in terms of what it would cost from gas, and then the transition across with the fabric upgrades calculated into that then that you would need to do. So maybe phase one, the shallow stuff, what would it be then? Phase two, what would it be then? And where is that sweet spot going to be, which, like I say, obviously can change. It's heavily caveated along with pretty much everything. But the key thing as well, like it's not the heat demand is important from that side of things, from like the cost side of things, but the transitions to do with the heat load, like I say, so if you can't get the heat load down to something around 60 watts per square meter, then that the heat pumps that you're trying to size to be affordable will not be able to heat the building in the coldest days, and they'll become uncomfortable. So it's kind of two-pronged approach. Do you know what I mean? You've got to make sure that the heat pumps are sized appropriately, and get the fabric down to that level. That's actually really the driver. Do you know what I mean? To allow you to transition to a decarbonised heat source. And then, like I say, taking then the kilowatt hours of that and multiplying it in terms of the energy costs.
And have you sort of done on some of these projects, works with different kinds of heat pump systems that different solutions for different buildings? Some aware that I've seen big sort of cascade systems, or lots of smaller heat pumps. Is there kind of just wondered if you could speak to sort of a bit more about that, your experience with different sort of solutions to this kind of problem.
So Amit from Ribca couldn't make it along today, so unfortunately I am just an architect and I don't know very much. I don't know huge amounts about heat pumps, but I do know from working with Amit, certainly for example on this project, which was the wider one, we were looking at, I think it was 5th generation heat pumps. So we were, it was set up in such a way that the heat pumps, each building would have individual heat pumps installed, which would be backed up by the water source heat pump, which would allow it to slowly decarbonise over time. And then as more buildings joined onto the water source heat pump system, that actually makes it more efficient. Do you know what I mean? And sort of cheaper to run, because it's got to cool down before it. The way the water source heat pump works is it's got to cool down before it comes back, essentially. So if there's not enough buildings connected to it, then it doesn't run as efficiently as it was designed. So, to start off with, there was individual heat pumps in the different buildings to get the load up to an acceptable level to keep it comfortable. But as more buildings joined it, we could start to switch them off, essentially. Do you know what I mean? And then it would become run fully from the district heating network.
Yeah.
So I don't know if that really answers your question or not. But
no. I think it's quite interesting, because I think a lot of people's heads, it's all about you think the transition from, I've got a gas boiler system, boiler house, whatever, and it's feeding and I need to decarbonize that and replace it with an equivalent heat pump system, but actually that might not just be a one-step transition. It could be something a bit more phased, and sort of part of a wider strategy, particularly as you say, if it's part of a collection of buildings or something in an estate. So yeah, interesting. Thank you. We've got a couple of questions in the chat here from Ada. So it was just one on, how long did you spend on the first part, surveying the existing buildings, conditions and tests? So like, how long did all that setup and methodology bit take to get to that point? And are the costs indicated just for the works or everything, including the use of clerk of works, evaluation, other specialists, and a question on for this particular project as well about why no solar thermal or PVs?
So the first part in terms of taking it, I mean, he get you to repeat the second bit, but the first part, it was certainly longer than what I'd allowed for my fee proposal. I can tell you that much. It was quite a big building, lots of different rooms. Thorough survey, you just walking around. That took quite a long time. The in situ U value calculations did take a number of months, because you have to run them over winter, really. Do you know what I mean, for them to work properly, so that you get the temperature delta between internal and external. So we were looking about 3 or 4 months getting them in early, getting the results back. I mean, we were working anyway in the background, kind of modelling and looking at the proposals, because there was plenty of stuff to get done in the interim. Doing the stone sampling didn't actually take too long. The biggest thing there was actually just get the lead-in time and trying to arrange people. It was Green Gauge that did it, and I think they were coming up from sort of Bristol area, so trying to get them up took a wee bit longer than probably it would have done if we were down in Bristol. But once they came up, they did the core in a day, and they were giving us results within a couple of weeks, from that, and then the woofy calculations 3 or 4 weeks after that as well. So I wouldn't have said it really held up, I suppose, I mean, we've probably completed the study in about 6 or 7 months, I would say, something like that. And sorry, what was the second part of the question?
The second part of the question was, just are the costs indicated for the works or everything, including use of clerk of works, evaluation of the specialists, whatever that might be, and then just that final little question around how come no solar thermal or PV on that particular project?
So the costs, the professional fees were just, I can't remember if it was 10 or 15%, but it was just a blanket percentage based on the construction value, on that one. So that was the allowance that was made. The solar thermal side of things, it was a Grade A listed building, so we weren't in discussion with the planning authority for it, but it was felt that it was unlikely to be permitted. Do you know what I mean, on the building, given its kind of listing? So we didn't take a cognizance of that. Generally speaking, when we are using the PHPP modelling tool, because we were looking at it from a passive house perspective, you don't need that in passive house. Sometimes you do, depending on a couple of different criteria, but generally speaking, it's not reliant on renewable energy like that. So quite often we don't look at that side of things. But certainly Amit had given us some numbers on what potential improvements it could be, so that if the planning authority were minded to allow it, then it could be introduced. And that's normally a pretty good option, to be fair. That is one thing that does tend to pay back, which is still solar thermal now because of the price of them.
Yeah, because I mean, when I saw this question around, like the PVs and stuff, I did think, oh, actually, quite a lot of flat roof or low pitched roofs that look like on that building, and I'm not an expert on planning, but I would have thought, oh, maybe there's potentially an opportunity there. you know, since most of the time you can't see that stuff from the street, and mostly planning tends to be concerned with, it depends on the listing, of course, but you know, the external facade and everything. So
we did one. So that was an A listed building. So it's as good as you can get in Scotland, you know. So that was part of the reason behind that. But we've done as part of the Strathclyde work we did, we looked at the Ross Priory campus, which has got a really beautiful Grade B listed building on it. And what we actually did there was this huge sort of campus, all rolling green fields and things like that. And we, for that site, we looked at a solar array, basically a ground-based solar array, just kind of remote from the building, that could then feed back into the building and power it. So you know, if you've got the luxury of that kind of thing, then it's definitely worth it. I mean, I suppose, like, you know, for the size of the building as well, I guess, and the area of roof that you've got for that building, then you know, the floor, you have 5 stories footprint versus what you can actually put on the roof. Do you know what I mean? It's difficult to get a lot of benefit, you know, but certainly it would be beneficial, I'm sure.
Yeah, and I think, yeah, I imagine there's probably a few people here in the chat thinking about solar PV, because we just had a question from Paul Smith around across solar on listed buildings and in conservation areas. Do you think it's time permissions were relaxed a little bit, around installing solar, given the pressures to reach net zero?
Yeah, I think so. I mean, it's I think probably planning authorities are maybe moving in that direction, but yeah, it's such a massive challenge that you've got to use everything. Do you know what I mean?
Yeah.
in your kind of arsenal, haven't you? You know,
tools off the table for yourself.
I mean, I'm not promoting putting beige render over the front of the buildings or anything like that. You know, but you know, certainly stuff like that, where, like you say, hidden away or putting secondary roofs and well, yeah, you wouldn't do it in that building, you know, obviously in a primary facade, but like you say, in a secondary facade, there's no reason why you couldn't have solar PV, I don't think.
Yeah. Just had another question from Amy pop up in the chat. She was just looking at, did you carry out any invasive surveys? So I think the answer to that's probably yes, given the the stone boring and stuff, which you might have missed at the start there, but I'll let you speak a bit about that.
I can run over it again. So it was basically we did some stone coring from the outside of the building, because the building was fully occupied. So we didn't do anything from the inside. I mean, we would be expecting it's just kind of some sort of lath or whatever plaster sort of build up on the inside. So we did the coring from the outside, and we took it away. And you might have missed that there was although it's one building, it was made up of 4 separate individual buildings, all of which were built at different times using slightly different stone. So we analysed every single type of stone, because they've all got different porosity properties, and as a result, that would impact what kind of insulation and what level of insulation we might use on each of them. But yeah, the stone cores were taken and analysed externally.
And I don't know if you've had a little look at the rest of that question as well, because there was just a little bit about I think the context there. Bramy was looking at doing some work on the Grade 2 listed community centre, and trying to decide the value in opening up certain areas. So I
think it's critically important that you do it, because there are so many risks involved in retrofitting listed and historic buildings with internal wall insulation. If that's what you're planning to do, you've really got to be careful and get that analysis carried out. So I would definitely recommend you get that done, just to avoid any unintended consequences like mold growth and things like that in the future. So yeah, do that analysis. Get some WUFI analysis carried out.
Yeah, it did almost frightened me a little bit, actually. The you know, we have that diagram with the joist and the wall there, and you know, the 50 mil of this installation's fine, but it hits 60 and you're suddenly messing with, I don't know, dew points or condense, and suddenly it's all going through that joist and beginning to rot it. I can see why people, you know, I guess unless you've really got that strong data to give you the correct decision to make, it, you can end up in a bit of, I suppose, analysis paralysis, you know, with it not thinking, 50 mil or 60, I could one wrong move here and you know, I'm destroying my building, you know.
Yeah, and you've got to be really careful as well, because like scenes like I'd shown in one of my plans as well, sometimes you'd be insulating internal walls in one room and not in another, which then worsens the thermal bridge. Actually, do you know what I mean? Over part of that where the the wall is joining. So you really do have to be pretty careful.
Was there any other questions that anybody wanted to ask Alistair, or are we sort of naturally winding down? I've just popped a poll, by the way, in the chat there for anyone that hasn't filled that in already. If you could, that'd be really helpful for us to understand a bit about your feelings around the session. And I've also popped the link to the Net Zero Hub's website on there as well. Yeah, we've got five minutes left if anybody wants to chime in with any last thoughts, but otherwise, yeah, I think we'll call it there potentially. All right.
Thanks very much.
Thank you very much. There we go. I think that's everybody. I don't think I can stop the recording.
Oh,
I didn't think. Oh no, I can. There you go. I'll stop it now.
Yeah, it's a pity Amit couldn't cover